Okay, so the first lesson in Unit 9 is a review for many of you in terms of balancing chemical equations. I believe that many of you have, at least at some point in your academic career, even in middle school, have balanced a chemical equation at some point or another. But if you haven't, we'll get through it together as a team. So there are some things that you need to know when you look at a chemical equation. So, for example, everything on this side of the arrow is known as a reactant. And that could be an element, or it could be a compound. Everything on this side of the arrow is known as a product. That also could be an element or a compound. It could also be an element and an element. It could be a compound and a compound. But long story short, it's going to be either some type of an element or a compound. And one thing that we can always say is that reactants make products. So that's kind of how we look at this. There is this arrow here, and the arrow is referred to as the yield sign. Which is sort of like the equal sign in math. So technically speaking, we would say that zinc plus HCl, which happens to be hydrochloric acid, yields hydrogen and zinc chloride. You would not say in chemistry that zinc plus hydrochloric acid equals hydrogen and zinc chloride. That's just not what you would do. There's also these big numbers in front of the compounds and elements. Those big numbers are called coefficients. I think I spelled that wrong, didn't I? Something like that. It's a coefficient, just like in math class. If you have something like 3x, the 3 is a coefficient. And then the last thing that you have in many chemical equations are these little letters down here, and those little letters down there are states of matter. To refresh your memory, there are 4 of them that we are going to be responsible for in chemistry: solid, liquid, gas, and aqueous, which we talked about before we jump back into lab. We will spend more time focusing on the state of matter in the second half of this week. But so for now, we just be aware that solid, liquid, gas, and aqueous are the states of matter that we're going to talk about. We also have the law of conservation of matter. So the law of conservation of matter says that matter cannot be created or destroyed. It can just be rearranged or change form. What that means is that no matter how much you like oxygen, okay, you can't just add oxygen to this equation up here, because there is no oxygen at the beginning and there is no oxygen, so there can't be oxygen at the end, okay? So it doesn't matter how much you like it, you just can't add it. And also, it doesn't matter how much you dislike zinc, you can't just lose zinc if it was a reactant. Question. Stretch? Okay, all right. So the law of conservation of matter says that when we have a chemical reaction, the reactants combine, mix together, separate, and form new products by a simple rearrangement of the atoms that are present. The other part about the law of conservation of matter that's really important to know is the amounts of each of these substances need to be the same on the reactant side as they are on the product side. So if I have something like 3 hydrogen atoms in some way, shape, or form on the left side, I have to account for those hydrogen atoms on the other side. So when we balance chemical equations, there's a few tips or tricks that might be helpful. One of the tips or tricks is that we can't change a subscript. So if you're given something like ZnCl2, you can't just arbitrarily decide that you want to make it ZnCl3. You just can't do that. That's not allowed. So you have to keep the 2 no matter what. So we balance chemical equations by using coefficients. So if I was going to balance this, I might put a coefficient of, say, like, I don't know, 3 in front. The law of conservation of matter tells you that you have to have the same number of zinc on the reactant side as you do on the product side. If the coefficients are able to be simplified, like if it's like a 2, 4, 2, 4 after you've balanced the equation, which could be simplified to 1, 2, 1, 2, you will want to do that. And then the last thing we want to kind of talk about is this polyatomic ion. So you might recall from your periodic table that you wrote the polyatomic ions on the back of your periodic table, right? Hopefully. If you see a polyatomic ion in a chemical equation and the polyatomic ion is on the reactant side, but it's also on the product side, instead of treating it as like individual elements, we treat it as one unit. So what I mean by that is if you see something like sulfate on the reactant side and sulfate on the product side, we can treat it as one unit. So I would say that you have like one sulfate here and one sulfate there. So you wouldn't have like one S and 4 O's on both sides. You just have one unit of sulfate. Does that make some sense? Now, the only way to get good at balancing is to practice balancing. Like, I can tell you all the tips and tricks, and there's other tricks that I can give you, but like it doesn't matter unless you do it. So that's what we're going to do first. We are going to balance chemical equations as a team. And here's how I do it. There's other methods out there, but this is the way that I do it. It makes a lot of sense to me. It also happens to be the way that I believe most of the other chemistry teachers in our department are doing it. So here's what we do. Step 1, I identify all of the elements on the reactant side and the product side, and I write them in a set of columns. So in the case of the first reaction, I have H and I have O on the reactant side, and I have H and O on the product side. I then go ahead and I count the number of atoms of each. So in the case of hydrogen on the left side, there's 2 of them, 1, 2. The case of oxygen on the left side, there's 2 of them, 1, 2. And in the case of hydrogen on the product side, there's 2 of them, 1, 2, and there's 1 oxygen. Does that make sense? Now, because I can't change subscripts, the 2's, I can add coefficients. So I'm going to go ahead and add a coefficient. But before I do that, I always start at the left side and I work my way to the right. So I start with hydrogen and I see that my hydrogens are balanced because I have 2 and 2 of them. I see that my oxygens are not balanced because I have 2 on the left side and 1 on the right side. So the only way that I can make them balance is by putting a coefficient of 2 here. Now that coefficient of 2 multiplies itself by every element that it's in front of. So that tells me that I'm going to have 2 times 2, which is 4 hydrogens, and 2 times 1, which is 2 oxygens. So at this point, if I go back and I check, I now have 2 oxygens on both sides, but I have 2 hydrogens on the left side and 4 hydrogens on the right side. So the only way for me to rectify that is to put a 2 in front of the hydrogen. And then, so that's going to give me my 4 hydrogens because that's going to multiply. And now both my hydrogens have 4 elements or 4 hydrogens on both sides, and my oxygens have 2 oxygens on both sides. It makes me feel better to have a 1 here because I don't like to leave things blank. But go.
I forgot my phone here
I
in HBS.
didn't see it after you left. Do you know?
No.
Well, just take a look around. Nobody said anything. Okay. All right. Let's do the next one. Again, I'm going to identify the elements that I have present. So I have aluminum, I have iron, and I have nitrogen. I'm just going to use this as some type of bookkeeping. So in this case, I see that I have 1 aluminum, I have 3 irons, and I have 2 nitrogens on the left side. On the right side, I have 1 aluminum, 1 nitrogen, and 1 iron, like so. I'm going to start going from left to right, so I'm going to start trying to balance my aluminums. I see that both of my aluminums on the left side and the right side are balanced because I've got 1 and 1. So I'm going to leave that alone. Now I'm going to move to my irons, and I see that my iron, I have 3 irons on the left side and 1 on the right side. So I'm going to add a coefficient of 3 in front of my iron on my right side. That coefficient of 3 is going to multiply by all the irons, and I'm going to have 3 irons on both sides now. So my aluminums still are balanced. I always go back and check. My irons are still balanced. I always go back and check. Now I need to check my nitrogens. In this case, my nitrogens are not balanced. I have 2 on the left side, 1 on the right side. So I'm going to add a coefficient of 2 here, which will distribute itself to the aluminum and the nitrogen. So that's going to give me my 2 nitrogens and 2 aluminums. So now I need to go back and check. My aluminums are no longer balanced, so I'm going to go back and add a coefficient to fix that, like so. So now I've got 2 aluminums on both sides, 3 irons on both sides, and 2 nitrogens on both sides. And everybody's happy. Yay. Now, in this next example down below, I grab my handy-dandy periodic table, and I see that I have polyatomic ions present in this next example. In the next example, I see that I have PO4, and I know it's PO4 because it's given itself a hug. It's in parentheses. So what I usually like to tell students to do is if there are polyatomic ions present, I give them all hugs. So I got PO4. I see PO4 in 2 places. I also see CO3, and I know that CO3, according to my polyatomic ion list, is carbonate. So I'm going to put a hug around CO3 over here and a hug around CO3 over here. And that means instead of treating carbonate as carbon and oxygen, it's 1 unit. So I've got 1 unit of carbonate, 1 unit of phosphate. In this case, I've got 2 units of phosphate and 1 unit of carbonate. So when I go to identify the elements that I have present, I'm going to start with calcium, with carbonate, with hydrogen, and with phosphate. And then I'm going to count. I have 1 calcium, I have 1 carbonate, I have 3 hydrogens, I have 1 phosphate. On the right side, I have 3 calciums, 2 phosphates, 2 hydrogens, 1 carbonate. So now I treat those as individual units of stuff instead of carbon and oxygen and phosphorus and oxygen. It can be balanced that way. It really can. It's just a lot more difficult. And if you want to be that person that wants to do things difficult, by all means, go ahead. I'm not going to do it that way. I'm going to start balancing as individual units. So going from left to right, I see that I have 1 calcium on the left side and 3 calciums on the right side. So I'm going to put a coefficient of 3 here that will distribute itself. So now I have 3 calciums and 3 carbonates. Going from left to right, my calciums are still balanced, but my carbonates appear to not be. So I'm going to go and I'm going to try to balance my carbonates. I have 3 on the left side, 1 on the right side. So I'm going to add a coefficient of 3 here, which will give me 6 hydrogens, but 3 carbonates. So going from left to right and checking, my calciums are still balanced, my carbonates are balanced, my hydrogens are not. So I'm going to add a coefficient of 2 here, which will distribute itself here and here. And so now I will have 6 hydrogens, 2 phosphates. Everybody's happy. All is right in the world. Going to put a 1 there because I don't like the way that looks by itself. Call it a day. Let's do a you try the next one. You try the next one. Ready, set, you try. So in this one was only a little bit tricky. And it was only a little bit tricky because after you identified that you had nitrate, NO3, and PO4, phosphate, you could then count the units, right? So we started out, right, with 3 sodiums, 1 phosphate, 1 copper, 2 nitrates, 1 sodium, 1 nitrate, 3 coppers, and 2 phosphates. And then we had to do some balancing. And the first set of balancing, we just used the 3, and that got us to balance our sodiums and our nitrates, or not our nitrates, and that kind of jacked everything up. So I had to go back and do it again. So in this problem, what I ended up doing was keeping that first attempt at balancing. I crossed it out, and then I went back and filled it in. So we ended up with 6 sodiums on both sides. We ended up with 6 nitrates on both sides. We ended up with 2 phosphates on both sides. And we ended up with 3 coppers on both sides. So in this instance, everything balanced out, but it took a little bit of going back and fixing, not necessarily fixing a mistake, but just fixing because that's part of the process. Questions? Now we need to talk about combustion. Combustion is a very unique type of chemical reaction. We are going to learn about the 5 different basic types of chemical reactions throughout the course of the end of the week, but combustion happens to be one of them. Combustion reactions are always a little bit more difficult to balance because they've got this weird little hiccup in them that we'll teach you a trick for. But they always start with something called a hydrocarbon. Which is some compound made up of carbon and hydrogen. So down below my example of CH4 is my hydrocarbon. Hydrocarbons, or carbon and hydrogen, that react with oxygen should be a dead giveaway that you have a combustion reaction. If the product is carbon dioxide and water, that's also a dead hint giveaway that you have a combustion reaction. And so there's some tricks or tips here, right? Some people balance the hydrogens first. I usually balance the carbons first and then the hydrogens. And then when everything is done, I usually balance my oxygens last. And the best way to do this is to show you an example. So here we go. So here I have a hydrocarbon, carbon and hydrogen, paired up with oxygen. So I'm going to identify my elements, carbon, hydrogen, and oxygen on both sides. I'm going to count 2 carbons, 6 hydrogens, 2 oxygens on the left side. And I've got 1 carbon and I've got 2 hydrogens. But now I need to show you that oxygen shows up twice. So it gets added together. So I have 3 oxygens on the right side. Okay. I'm going to start by adding a coefficient. So my coefficient of 2 to balance out my carbons, because I go left to right, that's going to give me my 2 carbons, but it's also going to give me 2 times 2, which is 4 hydrogens, right? But 4 plus 1 is really my 5 oxygens. Now I'm going to try to balance my hydrogens, right? I have 6 hydrogens on the left side. The only way for me to get 6 hydrogens on the right side is to add a coefficient of 3. So now I have 6 hydrogens, but I have 4 plus 3, which is 7 oxygens. Now, the easiest way for me to balance this is to simply take the number of oxygens and divide it by 2. 7 divided by 2, it's 3.5. Trouble is, you can't have half of an oxygen. You either have an oxygen or you don't. So we can't leave it like this, even though this happens to be balanced. So what we do is we then go ahead and we simply multiply all of the coefficients by 2, and now it's balanced. Magic. You can do it by trial and error, but this is the cheat code. At least my cheat code. So let's do another one. So we've got carbon, hydrogen, oxygen, I've got 1, 2, 3, 4 carbons. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens. And I've got 2 oxygens. I've got 1 carbon. I've got to add these situations together. 3 oxygens and 2 hydrogens. So balancing from left to right, I have 4 carbons on the left side, 1 carbon on the right side. So I'm going to go ahead and add a coefficient of 4 here. That's going to give me my 4 carbons. But it's also going to give me 4 times 2, which is 8 oxygens. But 8 plus the other one gives me 9 oxygens. So far, so good. I have 10 hydrogens on the left side, 2 hydrogens on the right side. So I'm going to add a coefficient of 5 here to get me to 10. 6, 7, 8, 9, 10. So now I've got my 10 hydrogens, but I've also got 5. So 5 and 8 is 13. So now I've got 13. So I'm going to take 13 divided by 2, and I'm going to see that that's 6.5. So I'm going to drop a 6.5 here, put a 1 here. I remember that I cannot have partial oxygens, so I'm going to multiply all of my coefficients by 2. And then everybody's balanced, and it's neat and clean and tidy. Questions? Excellent.